All right. So the one that we didn't do last class was D. So we're trying to find X star such that I'll let you guys read the rest of it while I erase this right here to give myself a little bit more room. I guess I could also just take out another piece of paper, but I'm already this far into it, so might as well just finish it up. All right. So let's see if you guys can walk me through the steps to complete this problem. Whenever we did this yesterday, how did we start this off? Ask if there's a Z, right? So we said, hey, if we're trying to find X star such that all of this kind of happens, we don't necessarily have a Z, but what we do know is that we're trying to find X star, right? So whenever we're trying to find X star, we're going to use our Z formula, right? So we said that this thing right here, the find X star portion of it, that's like our buzzword, right? Like even up here, I kind of have it marked from yesterday. That's our buzzword for saying, hey, we're going to use our Z value formula. All right. Then what was our next step? Awesome. So we're going to determine whether we're shading to the right or to the left. And if we wanted to find out if we're shading to the right or to the left, what did I always kind of do up here? I did something that was a little bit silly, but what was the next thing that I did? We want to figure out if we're shading to the right or to the left. Yeah, right? Like that's the thing that I kept doing. I kept scratching off this X star. I said, hey, like sometimes just looking at this X star kind of confuses people, right? Now we have this X and this X star up there, so how do we read this? I said you can scratch it off, you can put your favorite number up there. And now if you evaluated this, if you said, hey, X is greater than something, are we shading to the left or to the right?
To the right.
To the right, right? Because X is greater than something.
You can just follow the tail, right? So I think that's what we heard. So if it's like that, that's what we say.
No. So I'm glad that you said that, though, right? Because that's a very, very common mistake that people make. So what you're asking here is this, right? You're saying the probability of X being greater than X star. You're saying, hey, I can just follow the direction of this symbol, and that's going to be the direction that I shade in, right? That's what you say. So it doesn't always apply, because what happens if I write this, right? All I'm going to do is I'm going to switch the direction of these two signs. These two things are mathematically equivalent to each other, right? All I'm just doing is I'm changing the direction of the signs on the inside. Regardless, X is still greater than X star in the top one, and X is greater than X star in the bottom one, right? But now the direction of those symbols have changed, right? So that's why I'm saying sometimes what people do is this. Sometimes people just look at the symbol and at nothing else, right? And I think that's a question that you just asked me. But that in this situation, that would lead you to a wrong conclusion. So then the next thing that people usually get stumbled up on is saying, I have X's and I have X stars. Which one do I kind of look at? Blah, 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 blah. So that's why I'm saying, hey, just cross off the one that's new, cross off the X star. And if you cross off the X star, the one that's new, and just read this like we have been reading it before, well now, regardless of which one we are, if we're using the top one or the bottom one, here X is going to be greater than something, and here X is going to be greater than something. So both of these right here, we know that we're going to be shading to the right, right? So therefore here, we're going to be shading to the right on both of these right here. All right, is everybody good that we're shading to the right? All right. So if we're shading to the right, then, what percentage of the graph do we want to have shaded to the right? Awesome. Approximately 73%, right? Approximately 73% we want to have shaded to the right. Right, is everybody good with this? All right. If we want to have about 73% shaded to the right of some cutoff, is that cutoff going to be above the mean or below the mean? Below the mean, right? Does that make sense? If we want to have 73% of our graph shaded to the right of some cutoff, then that cutoff needs to be below the mean. Right? Is everybody good with this? So therefore, if our cutoff is below the mean, are we going to have a positive or a negative z-value? Negative z-value. So we're definitely going to have a negative z-value, right? So just like I said yesterday, that's what this huge positive sign was up in part C. Whatever we do from here on out, we have to end up with a negative z-value. Right? Is everybody good with that? All right. So now our next step is to do what? Go to the chart and go hunting for 0.7357. Right? So if we go to the chart and we go hunting for 0.7357, what z-value do you get? 0.63. Everybody good with finding 0.63? You go to a z-value of 0.63, you should find 0.7357. Right? Is everybody good with that? But 0.63 is positive, so what do we have to do? We have to just make that into a negative z-value. Right? Is everybody good with this? That's what we determined in that previous step with where our cutoff has to be, that it has to be below the mean. All right. So now we know that our z-value is negative 0.63. We're still trying to solve for x, or like our problem calls it, x star. But in this problem, we're also given the mean, which is 10, and we're given the standard deviation, which is 2.5. So at this point, it just becomes arithmetic. Right? Is everybody good with this? If you do this arithmetic, you should end up with x star being equal to 8.425. All right. How do you guys feel about this? The difficult ones, I think, are ones that are where you have something greater than, right? Whenever you have the greater than symbol, like x is greater than x star. Whenever we have x is greater than x star, what are we saying? Even though we have a small percentage, which we're expecting to give us a negative z value, because we're being greater than something, we have to, if we have a small percentage, we have to end up with a positive z value. Or like we did down here in part D, whenever we have x is greater than x star, and we have a large percentage, again, then above that cutoff, we want to have a large percentage, so we're going to end up with a negative z value. All right, how do you guys feel about this?
Really quick.
Yep.
Where did you get negative 0.63?
So we've looked up this percentage in the table, and if you look up this percentage in the table, you're going to get a positive 0.63.
Okay.
But we want to have a negative z value because we have more than 50% above our cutoff. Having more than 50% above our cutoff is going to give us a negative z value. All right. Any questions about A through D on this page? Yeah.
Not really a question, but couldn't you also, as like a first step, if you see the greater than sign, subtract whatever that 0.7357 from 1, and then just look for that?
Yeah. And that's kind of what Rachel suggested yesterday, where she said, hey, can't we just take this right here and subtract that from 1, and now we can do the same thing with this. The only thing that I want to caution about that is that, just like I said down here, it's not necessarily if it's the greater than symbol, because technically here you can also have the
Like
less than symbol.
when you determine it's to the right.
When you determine it's to the right, exactly. Yep. When you're above some cutoff, then you could take this and subtract 1 from 1. Yep. And then you're always going to end up with the correct one. Yep, that is perfectly okay. All right, any other questions about this? All right, then you guys asked to do a problem similar to one that's in the homework about getting A's in a class, right? So I think that the question in the homework, if I remember correctly, goes something like a professor wants to give the top 14% of students in a class an A. If it has a mean and a standard deviation, then what's the score that you need to get in order to get an A in the class, right? Is that the one that you guys are referring to? All right, so let's do it, right? We'll do one that's similar to it. Basically, what it's saying here is this. And of course, the main stipulation of this is that that grades follow a normal distribution. So our x is going to follow some kind of normal distribution. So if we have some normal distribution right here, let's think about this here for a second. If you're going to get an A in this class, what side of the distribution are you going to be on? The right-hand side, right? So here, what we're saying is that these students right here, these are going to be the ones that get the A, right? Because if you're thinking about grades, high numbers are a good thing, right? That should make sense. Now, so this is for grades. But let me ask you this. I'll do this a little aside up here. Suppose that you were looking at athletes who run a 40-yard dash, right? And you're looking at their 40-yard dash time. Is having a high 40-yard dash time a good thing or a low 40-yard dash time?
Low.
A low 40-yard dash time is a good thing, right? You take a stopwatch and you measure somebody's 40-yard dash time. If they have a low number, like 3 seconds or something like that, they're fast, so they're a good athlete, right? So therefore, if you're looking at the distribution for athletes and their 40-yard dash times, are the good athletes going to be at the top of the distribution or at the bottom of the distribution? At the bottom of the distribution, right? So therefore, the athletes that might go on to the next round of competition or get some kind of trophy or something like that, if you're comparing their 40-yard dash times, they're going to be at the lower end of the distribution. So those are two scenarios where good is at the opposite end of the distribution. Right? Is everybody good with that? So therefore, whenever you're trying to say, like if somebody goes, hey, I'm trying to measure something good, that doesn't necessarily mean that they're at the top end of the distribution. They could easily also be at the bottom end of the distribution. All right. So that was a little bit aside, right? So this is like 40-yard dash. But we'll call this a little aside. Now what we're saying here is that some professor, I think the professor's name is like Professor Mann or something like that, wants to give students in the top of the distribution an A. So let's just use a slightly different number than the homework does. Let's say that the top, let's call it the top 8%. He wants to give the top 8% of students in the class an A, so that's 0.08. All right. So then, what we're trying to figure out is, what grade do you have to get in order to get an A in that class? Well, that grade that we're trying to get, we're not going to report that in terms of a Z value, right? We're going to report that in terms of a grade. So what we're essentially looking for is we're looking for some X star value. That if you get this grade, you're going to get an A in the class. Right? Does that make sense? All right. So we're trying to find X star. We know that the top 8% are going to get A's. If we want to figure out what this is, what else do we still have to know? The mean and the standard deviation, right? Just like in the problems that we had before, mu was always given, and sigma was always given. I have no idea what these numbers could be. Let's say that the average is 78, and that a standard deviation is, 6 points. Is everybody good with this so far? So this is the setup of the problem. Really similar to what you guys saw in the homework, just some slightly different numbers. Cool? All right. So now if we want to answer this, since we're trying to find an x star, right? Remember, that was always our buzzword for using our z is equal to x minus mu over sigma formula. And you guys should be able to do these steps now, because now this is really similar to those types of examples that we just got done doing. All right, so let's do it. The first thing, the easiest thing is that I'll change this to an x star, and I'll plug in our mean, and I'll divide by our standard deviation. And now what we need to do is first this, right? This is going to be kind of a silly question because now we've already drew the picture. But we're going to give the top 8% of students an A. So therefore, we're looking to have, to the right of this, we want to have 8%. So obviously, we're shading to the right, right? We're shading to the right, and we want to give less than 50% of the students an A. So we have less than 50%. So therefore, naturally, we should be looking for a positive z-value, right? So everybody good with that? So we have to have a positive z-value. So whatever we do from here on out, we want to have a positive z-value, right? Joshua, this is where you would say, hey, I want to shade to the right, so I'm not going to look up 8%, I'm going to look up 92%. That's the question you just got from us. Right? All right, so now I just told you guys what the next step was. The next step is that we're going to be looking up this 8%. If you go looking for a z-value that corresponds to a percentage of 8%, what z-value do you get? Not 0.5319. Not 0.802. Good question. So which two numbers are you looking at? Awesome. So let's take a look at those, right? So what Rachel is referring to here is this. If you look at negative 1.4 and negative 1.41, these two numbers are as close as we can get to 0.08 or 8% on our table, right? Can everybody see these? Yeah, huge. You could literally still be out in the parking lot and probably still see this, right? As long as you can see through the walls. All right. So we're looking for 0.08 because that's a percentage of the distribution that we want to have above the mean. If we go hunting for 0.08 right here, we're going to see that we don't have 0.08 on our table, but the closest two numbers that we get are these two numbers, and 0.08 is somewhere in between here, right? So now, Rachel, your question was, do we round up or do we round down? And the answer to that is, it depends. But here's what it depends on. We want to be at 0.08, which is somewhere in between here. Which one of these two numbers is closer to 0.08? Right? This one's just a tiny little bit closer to 0.08, right? Like this is 7 10,000ths away from it, and this is 8 10,000ths away from it, right? So technically speaking, 0.08 is just slightly closer to this number right here. So therefore, this would be the number that we want to use, right? Now, about that, right? We're like down in the 4th decimal place right here. If you use, for some reason, like if you're on a test and you're flying through stuff and you use this number here instead, your answer is going to be so slightly off. I'm never going to have two answer choices that are so close together that it's going to penalize you if you choose this number versus choosing this number, right? So technically speaking, you could use this one and you could use this one. The way that the answer choices are going to be calculated are going to be using this one right here because this one's slightly closer. But technically speaking, you could even use, instead of using negative 1.4, which is this number right here, or negative 1.41, which is this number right here, because 0.08 is somewhere in between here, you could use a number that's in between these two right here, which is negative 1.405. Right? Because negative 1.405 would just be right in between here. So you could also use that number if you want to. We're not going to get into that in this chapter, but once we get to chapter 7, we're gonna use that concept a little bit more often. Where if we want to be right in between here, then we could either use negative 1.40, negative 1.41, or we can use negative 1.405. Now, this negative 1.405 is just an estimate, because remember what we're doing here is that we're taking the average of these two things, right? Negative 1.41, negative 1.45. And taking the average of those two numbers is technically, theoretically, incorrect, right? Because you still remember whenever we were looking at that one sliver, and I blew up that one sliver, that 34% sliver, and we said that our intuition tells us that 17% should be on one side and 17% should be on the other side. But then when we blew it up, we saw that that was impossible to be the case. What we're doing there is we're trying to take the average of those two things. We're trying to say half is here and half is there, right? So technically this wouldn't be correct. There should be a little bit more that's on this side than is on this side. Then we're just getting down to like the 5th decimal place, so all that stuff doesn't really matter. All right, so that was a long-winded answer for it doesn't matter, right? You can use whichever one you want. All right, regardless, is everybody good for why we're going to use negative 1.414? Negative 1.41. All right, so now what we wanted to do is we want to use negative 1.41 right here, but the important consideration is what? Yeah, we want to use the positive, right? Because here we said that our cutoff needs to be above the mean, so therefore we want to have a positive z-value. So we're simply just going to get rid of this negative sign right here. And then, Josh, if you looked up 92%, then if you looked up 92%, you should be in this number right here. And now it's just arithmetic. So whatever this comes out to be, this would be the same way then that you would calculate out that homework problem. Is everybody good with taking that homework problem now and comparing it to a problem like this? I think somewhere along the lines you're going to see a question about, I don't know if it's 40-yard dash times or if it's swimming or something like that, but it's where having low times is a good thing. And then here all you would have is, this would be almost exactly the same type of problem, except that here we're going to want to have a negative z-value. So once you look up negative 1.41, then you would just hold on to that negative number. All right. Any other questions about chapter 5? Everybody's good with chapter 5? All right, then what I'm going to do is I'm going to start a new video.